synthesizes the third dimension. So if you don't understand, it will be called further. Now tell me, am I in front of you or the projector screen is in front of you? Yes? Am I in front of you in terms of near to you, or else I'll ask you like this. Am I near to you or the projector is near to you? Me? Okay, so you are measuring the depth information, the third dimensional information you are getting because of this two. You have a binocular vision. Actually, your left eye sees the image and the right eye sees you don't see it separately, whereas your brain synthesizes the third dimension. Okay, this is what happens in remote sensing for generation of the three-dimensional information also. Fine? I'll show you how it is being done. So the ground sampling distance is nothing but, you might have seen the tile, right? The size of a single tile is nothing but the ground sampling distance. What is the size of a pixel, single pixel on the ground? So when India started its remote sensing program, it started the size of the one pixel was 72 meters. That means what? Your 100-meter track will be shown in how many pixels? 1.3, somewhere or 1.5 you will take 1.5 pixels. When I tell you that I have a resolution of 1 meter, 100-meter track will be shown in how many pixels? 1 meter is the size of a pixel. 1 meter is the size of your tile. Your 100-meter track will be shown in how many pixels? 100 pixels. So the resolution of the data is much higher, and when we call the ground sampling distance is smaller. And when we are talking in terms of aircraft, we talk in terms of 5 to 30 centimeter is the size of the pixel. So then what happens? I see it in much more detail. When I come to drone platform, I normally talk in terms of 2 to 5 centimeter. And further, I can see very clearly on the drone. Okay. So that is nothing but the ground sampling distance, which is nothing but the pixel size on the in your camera, whatever it is, the micron, divided by into h is the distance at which you are seeing. In case of remote sensing satellite, what will you put h? H how much? H of flying height. This is nothing but the flying height and divided by the focal length. So h is going to be around 600 to 800. Your focal length is going to be 1 to 2 meter or 10 meter, whatever it is. So whereas when I come to aircraft, I am going to be around 1 to 2 kilometers. So I get a better GSD. When I come to drone, I am going to get 100 to 120 meters. Naturally, my ground sampling distance is going to be still less. Have you discussed about SWAT in the first class? SWAT, no? Okay. So I will not go into it. Okay. Fine. Next. What I want to tell is there are different platforms that are used to generate the current information. Next. Okay. So slide definition maybe for the next 2 slides. If you are going to sleep now, I will ask you questions. Okay. So what is photogrammetry? In photogrammetry, first forget about the first paragraph which you have to write in case you are doing a photogrammetric course and you are writing an exam. What we are going to do in photogrammetry is from an image you are going to make measurements. That's all. In photogrammetry, what you do? Use images, or in the earlier days it used to be photographs because it used to be, I don't know if people know whether it is, I don't know whether manual photographs you see from cameras. Now all in the digital era, no? Hard copy, we also started with the hard copy digital photographs. Now it is all digital ones. We make measurements from photograph to get the geometric information and semantic information. What do I mean by geometry? Measurements, length, area, or something. What is semantic? If I see from here, semantic is what? This is tile, this is chair, that is a wall, that is fan. describe the object is called in the semantic information, and I tell each tile is going to be 2 feet by 2 feet is that tile length. It's a measurement. So what I am going to get is using images, I am going to make measurements, and I am also going to tell what is that object. Whether it's a road, in this case, I have told you an example of semantic information here. When I am doing with an aircraft or this one, I am going to tell whether it's an agricultural crop, whether it is a road, whether it is a forest, or it is a built up, that is buildings, similar so on and so forth. Okay, railway line, different objects on the earth. Okay, so these are the two things we are going to make measurements and also have defined what the scene contains. Next. Okay, so coming to this one, as I told, we have a digital camera which will be fitted to the belly of the aircraft, and then we acquire the data. With that, the pixel size, that is the ground sampling distance, is going to be 5 centimeter, and then it has got when I tell panchromatic, it is black and white. Multispectral means color. Near infrared, color infrared means it's one. This is the natural color composite, and what is this? Anybody can guess? It's written there, no? Okay, it's written there. Lal Bahadur Stadium of Hyderabad. So these are all the information that you will get. Okay.
So what is the fourth channel here?
This is the infrared. Color infrared type. Red, green, blue, green, red, and then the infrared. Because this infrared, can you see? Normally this shows the vegetation becomes dominant when I use this plant. You can see this, no? When you see this image, and then I put that to same resolution. Can you see that the vegetation comes out very clearly in this application, in this data?
Means green dominant.
No, infrared dominant. Infrared information is added to generate a false color composite.
So
See, what you have to do is you have to feed the green into the blue channel, red into the green into blue channel, red into green channel, and infrared into the red channel. You get that? This is called as a natural composite. This is called as a false color composite. Water body will come black, and the vegetation will try to dominate.
Can I use this for normal images, 4 channel?
But where is the band? You will not get in all your mobile phones. That infrared, we have special cameras actually. Maybe when I am discussing about the drones for agriculture and some of these applications, and even we have some of the applications require thermal band. We have what is called as the red edge and the near infrared band. See, the red edge and the infrared, red edge band is normal. Actually, I don't know whether NVDA and all are covered. No? You have, people know this? No. Okay, not enough. Okay, fine. Because I should not go too much of so many things in 2 hours. It will go the other way. Okay. Just to tell you that this information brings out certain other information. So I am see in all the slides I am not going to talk about everything. Okay. I leave certain things because at this level not required. Maybe if you are fascinated about it, we can discuss separately based on your requirement. Fine. Next slide. Okay. The topic is there. My topic is this one, right? Yes, no. I have been asked to speak about terrain modeling and its analysis. They told I slightly reframed it to applications I made it. So that analysis to the real life applications I just want to show. So, is this clear for you? What is clear? See, I think maybe if you are hearing this in our always when we go for promotions, no, within our organization for the next grade promotion, this is a standard question for us. What is the digital elevation model? What is the digital surface model? What is the digital terrain model? Okay. See, what I will tell you is I will come to the DEM little later. what I want to tell you is, I am seeing from the top. I am seeing from the top. Okay, and then in the ground, if I see from the top, and imagine. Okay, fine. See, when I want further, I will cover. When I see here this working again. It has gone somewhere. No, friends. Okay. See, what we are seeing is, I think I tried to do this with this. Suppose imagine if I try to see from the top, or I put a torch from the top. When I put the torch on the ground, the reflection is going to come from the ground, and then it is on the top of the tree. It is the top of the tree, again ground, top of the tree, ground, top of the building. Suppose if I see from the top, the first reflective surface, if I see from the top, suppose if the room is not, I just laid the floor tiles. Only tiles is nothing but the terrain model. Suppose if I go to if I go to moon, what will be there on the surface of the moon? What will be there on the surface of the moon? Only the terrain will be there. Suppose when I occupy there, what I will do next? I will construct buildings. I will put roads. If required, I will plants are required, trees are required, I plant. So that terrain model will become terrain cum surface model. You are taking the point. If it is the highest elevation of each point coming from the ground or above ground area is called as the surface model. This yellow line is nothing but the surface model. What is the terrain model? In the absence of man-made and the natural features, only the barren represented by the red points is nothing but the terrain model. Clear? What this shows? This shows a river, buildings, other water bodies, and these are all the agricultural fields, everything. So when I remove trees and the man-made feature, what you get is called the terrain. So this representation is only the red points, whereas this represents the yellow point. Are you clear? Are you clear? Are you clear? Yes, next slide. Good. So in the case of aerial camera, aerial camera, we take this data through a set of process which is called as you have the platform, you do the flight planning, and you have the set of processes like GNSS and GCPs, and you do subsequent process. Don't get into the detail of it. And then we are going to generate different products such as the surface 3D feature extraction, digital terrain model, and different things. Don't worry about that. Basically, we are going to generate, taking the platform and the sensor, take it through set of process, and then derive the outputs like terrain models, 3D feature extraction, and all that, which I'll show you in the subsequent slide. Next. Okay. For what we have to do is, if I want to acquire data using an aircraft, how I am going to acquire a given area? Suppose the user has given this is the DG-80 campus. Imagine for a minute. I want to acquire suppose an aircraft data or a drone data. I have to cover in a systematic fashion. So, say systematic coverage of a given area using an aircraft or a drone is called a flight plan. Simply I cannot fly left, right, and center. Okay, so this is called as the flight plan. Next. Okay, so as I told you before, in the case of aircraft, I am going to acquire the photograph at different. Go back once. See, these are all the points. What are the red points? Suppose if I am flying this line, I go along this line and take the next line and come, take this line and keep on capturing the data. These points, red points, are the points at which I am going to trigger the camera. Understood? I am going to acquire the data of this area. My aircraft takes off. I click here. I go next, click the data. What happens is, as I told, I want to get the three-dimensional information. To get the three-dimensional information, what I have to do? There should be a common area between first image and the second image. Next, go to the next slide. This is called as the overlap. I acquire the data from the first location and acquire the second data from the next location. There is an overlap. When I put my eye in a system, left and right eye, I bring back the terrain in 3 dimension on the system. Have you seen 3D movies? Huh? The same thing, what they give extra to you when you are watching a 3D movie? The 3D glasses. That's what exactly happens here. So he takes 2 cameras and gets the depth, and with the polarized glasses, you are made to see the left image sees the left image, left glasses sees the left image, right eye sees the right image, and then you reconsider the 3-dimensional information. Exactly same thing happens. So this is called as this 2 or any 2 is called as the stereo pair. Once I see this one information, I see what happens if you want to go to the ground. What I am doing here is I am bringing the 3-dimensional information onto the lab, and with the computers and special glasses, I can bring back the ground information onto a lab on a system to carry out the measurements. Fine? Clear?
Sir, for this directly we can go for convolution during the course.
What do you do?
Suppose once if I get all the direct information, I can overlap and get the information. Why I should? Photography is doing everything. What is the process? What is the role of AI here?
Role of AI, I don't know, because I am not an expert in AI. To be very frank, whether you can synthesize, I was told you can synthesize stereo with the AI. Is it possible?
No, sir. You have the information overlapping it, right?
Yes.
With this, will they go for further processing?
Yes, I will show you that. Where Cse-Aiml, ultimately Cse-Aiml is going to be used in an area where the manual effort will be replaced by the system. Through how the man does by manual method, you are going to train the system to get this information. Okay, so this is how it is. This is called as a stereo pair. This is required to get the 3-dimensional information. There is some overlap in the other direction, so that there should not be any gaps. Next slide. Next slide. Okay, so this I told already. This is what happens to get the stereo. What you do is, you are seeing the refers to the apparent change in relative position of a stationary object caused by the change in viewing position. So how I am going to get the stereo is, you are a stationary object. What I am going to do is, I am going to acquire the data from one location and go to the next location and get the one more image. When I have the stereo pair, I am going to get the depth information. This measurement is called as the parallax. This is called as the X parallax. I am not going to the Y parallax and all that. See, we are ultimately using stereo information with 2 images with an overlap of 60% or more. We are going to get the stereo 3-dimensional information using 2-dimensional data. One image and another image with the overlap, and I have a special devices. I can bring the 3rd-dimensional information and carry out measurement. That is photogrammetry. Fine. Next. Next slide. Okay. Again, just I want to tell you is, when I am taking image from the platform, what I see on the ground directly, there will not be any shift. When an object is away from the center, the same eye tension gets displaced. You are getting it? So this is the displacement. This is called as the relief displacement. So you have seen this formula, right? Okay. Again, this h is the flying height. Okay. Just tell me if h is the flying height of the platform. Where the relief displacement will be more? Which platform will have more relief displacement? Because 100 meter is drone, 2 kilometers is aircraft, 800 kilometer is going to be the satellite, where the relief displacement, shift of the object. Suppose I don't know, I think day in and day out you will be crossing Gachibowli, right? People will be traveling mostly via Gachibowli, right? If I have a 40 floor, 50 floor apartment and I get an image of that area, what will happen is the 40 floor building, each floor is 3 meters, assuming 3 meters. 40 floor is nothing but 120 meters the height of the building. Okay, that is the small h. Okay, don't worry about the r. H is going to be the flying height of the platform. So h is going to be 800 for satellite, 2 km for aircraft, 100 meters for this one. When h is the denominator, what will happen? Which will have relief displacement less. Relief displacement is nothing but leaning of the object when I move away from the center of the image. Which will be more, relief displacement will be more in which case? It's in the denominator. Then d will be less in what? Huh? H is the flying height. H is the flying height. 100 meters I am here with the drone. H is in the denominator. 800 kilometers is the denominator. Naturally, relief displacement will be less in the case of satellite data. Relief displacement will be more in the drone will be very much higher, and in case of aerial it will be more. In case of increasing order means relief displacement is more in drone, then less in when compared to drone, less in aircraft, very less in satellite. Okay, next time. Again, coming to this, in the case of the processing, the GNSS technology is being used in photogrammetry for 2 points. You have been taught or told about geometric correction? No? First class? No? Okay. So basically, if I want to stick this poster, what will happen? What do you require? Normally, how will you fix the poster? Glue. Where you require the glue? Back of the folder. What are the exact location of the poster? What location is normally put? Corners. Means to start with corners. If it is a span is less, more, then you put in between also. To fix this one, this is a normal image. Whereas I am talking about geography, I have to get suppose BGIT data I acquired from the top, and I want to fix at the correct location of BGIT. You know, it has got a coordinate. BGIT has got a coordinate. Yes. In terms of what? Latitude, longitude, and height. So temporarily forget about the height part of it. Latitude and longitude. So how do you get this longitude? Previously, civil engineers are there. They will use conventional techniques like theodolite and all that. I will not get into it. Now, if I want you to get the coordinate of this, I want you to share the location of VGIT. What exactly you do? What exactly you do? VGIT is put naturally transmits me your coordinate only, right, to me. So that coordinate information, in the case of a normal poster, it doesn't require a geography. Whereas when you are handling geospatial information, you require geography. For that you require the location information. That location information previously used to come from conventional civil engineering techniques. These days we use GNSS technology. Okay. When I hire Uber or Ola, I give my location, right? When I give my location, it will just tell me your location is approximate, right? What it will tell? Your location may not fall exact. You are in the dining room or the living room of your house. You share the location on the Uber or Google, this one, Ola. It will be showing somewhere outside the house and somewhere on the road. And the accuracy, it will tell it varies. Your location can be approximate up to 10 meter to 15 meter. Correct? So that comes because what you use is not semantic. It uses what is called as the navigated information. See, for navigation, I don't require accuracy. See, normally in the case of GNSS, maybe can you go to the next slide, please?
Right.
Okay, so a GNSS system normally gives you position, navigation, and timing. Timing part is forget about it. Okay, because I can keep on speaking about it, it will be boring for you, and maybe you may leave in between also. I don't want to do that. Huh? Okay. Then navigation part, you day in and day out do it. Navigation part, where you use any travel, you are using the navigation part. This normal with the standalone system, the accuracy can go between 10 meters to 15 meters. 10 meters to 15 meters. Okay, for navigation it is good enough, right? Navigation is good enough. But for when I am handling data of 5 centimeter, 10 centimeter and all that, that is not good enough for us. Okay, so the problem is, I think you asked one of your research scholar told. He told nicely what are the different GNSS systems. You have a board there. Can you just okay, there are different GNSS systems. Okay, the big process. Okay, so there are different navigation systems available around the world, and India system is not a global one. It is only, it extends India and 1500 kilometers beyond. Okay, so it's a regional system. So what exactly happens in case of GNSS is, okay. So see, basically in the navigation mode, this system can give an accuracy of around 10 meters to 15 meters, which is good enough for navigation. But for precise applications, this is not good enough. So we have to do a different concept as the differential processing, which cannot happen real time. You cannot ask centimeter level accuracy or sub-meter level accuracy in real time. Okay. So before that, I will just explain how. Not possible. Yeah. Okay. So basically, how navigation satellites work is, you have 4 satellites. Can you go to the next slide? These are the 4 satellites. Your location is here. Okay. Basically, what happens is, in the case of GPS technology, to derive your position, you require the location of 4 satellites. Location of, that is X, Y, Z of the satellite, S1, S2, S3 and S4, and the signal travel time to your receiver. That is, even in your mobile phone you have a GPS chip which measures this one information. Based on this timing of the signal and the location information which comes from as part of the signal, I am not going into the code, carrier and all that, because again you will run away from my class. Okay, which I don't want to do, because seeing 2-3 people leaving, I just brought my level down. Okay. Fine. So what happened is, to derive your position, you require position of 4 the location of 4 satellites and the signal travel time from the 4 satellites to derive your position. Which, when you are operating your mobile receiver, do you feel it? Background, all this process happens. And this accuracy is going to be around 10 to 15 meters. Whereas when you are operating a data of 2 centimeter, 10 centimeter data, you are telling that the glue has to be at the correct location, right? Glue cannot be out by this much distance. In the fixing the poster, location cannot be inaccurate. So what we do is, again I am skipping this. The space segment is the satellite part, and we are part of the user segment. The control segment does this location updation and all that. Don't worry about it. Next. Okay. What happens is, location of 4 satellites are required. You measure range and you derive the location. But these satellites are at an altitude of 20,200 kilometers. It has to pass through ionosphere, troposphere, all different layers it has to pass, it has different errors. That's why it is called as not an actual range, it is called as a pseudo range. That's why your error is this much. Minus all this disturbance, no? Your accuracy should have been less than a meter. Because of this error, your accuracy is between 10 to 15 meters. Next, I'll share the slide, but next. Okay, these are all the sources of errors. Again, I don't want. These are all errors which results in your navigational error of 10 to 15 meters. Next. Okay. Then we do what is called as the differential positioning. What happens? Don't worry about that. In order to bring this accuracy to centimeter level, you use carrier. If you want to come to sub-meter or so, use the code. Carrier and code I don't want. Maybe you can discuss with your ECE teacher what is the code and what is the carrier. Okay, but this cannot be done. Differential processing cannot be done real time. Real time corrections can come. I don't want to complicate. What I use is I use two receivers on the ground. I put one of the receiver in the known point and try to derive the coordinate of the other point to bring the accuracy to centimeter level. This is called as the differential processing. We do differential processing because the resolution of the data, what we handle is in the centimeter level. Clear? Fine. Next. Again, in the case of what happened, this is for getting the nail or the blue point for a geographical data. In the case of aircraft, no, what we do is in the case of aircraft, when it is taking images with the camera, I put one more receiver on the ground, and I process this data differentially to get the centimeter level accuracy for this platform. Understood? If I go with the aircraft alone, what will be the accuracy? 10 to 15 meters. That is not suitable. So I use a differential processing in case of, see, you have a reference receiver and you have one more receiver on the aircraft, differentially processed to get the centimeter level. Next. Okay. This is nothing but okay. And this is nothing but again a differential concept that is for fixing the trajectory of the platform. This is for getting the coordinate of your blue point or the nail to fix the image. Okay, fine. This can be away, I think. Okay, next. Just to tell you where should be your glue point or your nail point. In the case of this is an image, this is corner of a culvert, so that you get precisely fix the image to the correct location. Next. Again, I don't want to get into this. I don't know whether you know mean sea level. Have you seen mean sea level? Where you normally see this mean sea level? Beaches, what will be the level? Zero. Have you ever seen taking a GPS receiver, because the GPS receiver measures height with reference to ellipsoid. But whereas in whatever Google you handle, you will apply what is called the geodal correction. Because normally when you handle the GPS, you will get, when you go to the Vizag coast, your height will be around -70. Okay, I don't know whether you people have that, but I don't know, in Google they will try to handle it. They will apply the geodal correction and they make it zero. Because this American system works on what is called the WJ84 ellipsoid, and your height should be lesser than, as far as India is concerned, height will be negative. But you will apply the geoid correction so that it becomes, as you told, near the beach it should be zero. Okay. Suppose in Hyderabad you will not be able to locate because it is going to be around variation of 60 meters. Normally if you go 540 meters, show us 480 meters, you will not know. But mostly in all our applications they would have done the ellipsoid with this geodal correction. Don't get into it. Next. This what I want to tell in interior orientation is this is nothing but the camera specification in terms of the focal length. Okay? And other distortion parameters. Interior orientation describes about the characteristics of the camera. Fine? Close. Next. Okay. Then what happens is now I have acquired stereo. Fine. Now I have acquired stereo images for a given area. Initially I told when I have two images there is a common overlap. Like that I continuously acquire. No? To have a uniform seamless integration of this data, we go through a process called block adjustment and error triangulation. What I do is I have stereo images to establish a relationship so that I can see uniformly everything the given area in stereo. We do this two process what is called as error triangulation, block adjustment. Close. Next. Okay. So we started sometime back immediately after the World War II. Analog big systems working on some hard copy and diagnostics. Then it became analytical. Now it is like a system. This is the digital photogrammetric system which we use for generating the digital terrain model and other things. Next. Okay. So what happens is whatever image I acquired, no, I cannot see. Can I do measurement from any of the maps? I don't know whether you have seen some maps from Surveypedia, the nodal agency or something. No. Or you have seen atlas. Can you do measurement from the atlas? They would have given the scale and you can measure and you multiply by the scale. So you can make a measurement from maps. But from the images, be it aerial images or the satellite image, directly you cannot make a measurement because it has got two errors. One is the tilt of the sensor and the other one is the relief of the terrain. The terrain is not flat. Okay, the terrain, see, whereas you see this floor, it's a flat terrain. From this terrain to this terrain, there is an undulation that is not correct for relief. So you cannot make measurements on aerial data or approximate measurements you can do, but again you cannot take for a very rolling terrain, like you cannot take it to Himalaya. It will show in 2 dimensions, you cannot make measurement. So it has to go undergo a process called orthorectification because of the relief of the ground and also the tilt of the sensor. Whereas you can make measurements from the map. To make an aerial image or a satellite image, to make it suitable for measurements, you have to do a process called orthorectification. Clear? Close. Next.
So orthorectification means 3D is converted into 2D.
Yeah, 3D is converted into 2D, and what a nice question actually. What happens in all the images? You suppress the Z dimensions using a terrain model. See, what I do is, you know the interior orientation parameter, camera characteristics from here. You know that terrain information. At the terrain be not here, what happened? This point would have met to here, this point. Correct? This point minus the terrain would have reached this point. This is the impact of terrain. And there is going to be a tilt. And so what happens is you have to do an orthorectification to convert the 3D into 2D, and then with this information you can make a 2-dimensional map. The elevation will not come into play. Next. Okay. So this is what I told. What you do in the case of map is an orthographic projection. In the case of an image, it's a perspective projection. To convert this perspective image projection to the orthographic projection, you do what is called as orthorectification. Fine? And you get only 2-dimensional information. This is to getting the 2 dimensions, that is x and y only. You do not get the z. If you want to get the z, you require a photogrammetric system. Take the don't do an orthorectified image and get the 3rd dimension. You will not get the 3rd dimension. Okay? There was one person who came from NRC who told take orthorectified image and get the 3 dimension. No. With orthorectified image, you will get only the 2-dimensional information. Because map gives 2 dimensions only, no? That the contour information is the height. So in this case, if you want stereo, you take the 2 data sets with left and right overlap and see on a stereographic system, and this was manually captured. To capture manually, where you require AIML experts to generate what AIML experts normally do. What AIML experts normally do? They take one, they bring the road alone. Take one thing, get the buildings alone. It's ultimately what you require is a map or a building model or something in all aspects. Maybe you can start with 1 to 2 feature initially as an AIML problem. Ultimately, what we require is that can see what I told is 0.1 square kilometer. The operator sits in front of the system. One man day, 8 hours, he sits and captures 0.1 square kilometer. Can I do all this process using the AIML thing? Is going to be the thing. Next.
Sir, what is auto image? What is auto image?
Auto image is the one which is rectified image for the tilt and relief. This one. It is nothing but a photo map where I can make measurement from this image, from this image, but it provides only the 2-dimensional information. I can straight away map a 2-dimensional map from that. But normal image of an aerial or a satellite image you are not supposed to do because it has got relief and terrain errors. Next, these are all the products. One is the terrain model, you know. This is actually a coal mine. I don't want to get into this. This is an ortho image and this is the perspective image of it. Next one. And again I told this is for I will not get into the detail of it. This is used by National Informatics Center. We are done for 3 cities, basically for urban planning, tax collection. I think you might have heard about this in recent times, no? The tax collection, solar potential related studies and all that require this type of 3-dimensional models. Why? Why you require for solar potential a 3-dimensional model? Okay. Not only this, it requires a tree also. No? Suppose you put a solar panel on top of your house. Adjacent there is a big banyan tree. What will happen? Okay, these are all the things, modeling and other things. What is the effective, what is the type of solar panel? Because what is the area of your terrace and what is the dimension of the solar panel that I have to put to effectively use that for different solar renewable energy projects. I think the government of India is coming with for major cities, nearly 100 cities and towns, generating this information using drone and other platforms. Fine. Next. This is for a railway alignment project. I think I don't know whether you have heard about this Kasigan. I think this project is now operational. We have done the elevation model, and what you see, these lines are contour lines. What are contour lines?
The line which states the sea level of the particular area.
Correct, but can I tell the contour has come? Good. Yes, it's an ISO line connecting points of equal heights. Line connecting points of equal height. Okay, this contour information. This is basically comes from the terrain. Okay, so this is the project, and we want to get into it. Next. I think you have heard about the Chandrayaan mission. Okay, so we have provided the lander. See, for the lander to come down, it has to use some of the sensors on board. It has got an altimeter, laser range finder. So how you will check the performance of a because it goes to moon, but we have to test it in, on the earth, right? We have given the elevation model. So that onboard sensors, are they getting the right elevation with the onboard sensors, and we have given the reference depth for that. So that the lander has to land on the surface precisely. Fine. I am again not going to get into it. Just an elevation model is being generated from the aerial data. These are all artificial craters. This is at Chitradurga. These are all the artificial craters. What is there on the moon is being simulated on the ground. Okay, so that it has to be away from the what is that called? It should not land in a crater. Next, this is for Indian Air Force we are done. This is for the flight simulation. See, see a pilot has to be trained, right, for different terrains. So you cannot try a MiG or something on the real ground. So you use a simulator. Even these days, drone pilots also being trained on simulators before they get into the real drone operations. So this is Shohapur in Uttar Pradesh. This is what is the auto image trained on a terrain model. You are clear? Terrain model is there. On top of it, we have read the image, so that you are getting the perspective, right? Correct? You are getting. Had this been not there, if I give you a why I told you, you cannot measure from the aerial photograph I told. Auto image you can measure. Had it been image, this relief effect would not have been taken into account in a normal image. So you have to auto rectify it. Fine? This is used for any flight simulations. Next. This is, anybody can guess? It's very near to you. Usman Sagar. Okay. I don't know where is your college here. I don't know. Fine. But this is the place, and this has been previously the operator used to get the individual elevation points manually. Now we have the computer vision techniques which derive this digital surface model by image matching techniques automatically. Have you heard about image matching techniques? Yes, no? Only teacher is telling, teacher is not answering, I think. Huh? Research scholars? Image matching? No. These are all automatic using the stereo image from aerial camera. This is for this has been taken up for urban flood modeling for Hyderabad under the disaster management support program. Next. Anybody? Okay. Hussain sir, what is this? Okay. Next. Okay. See this, we are seeing how this surface model is being generated from aerial image camera through image matching techniques. Now we are going into the concept called LiDAR. Okay. Just I want to tell you that next slide. Are you here? Okay. How the LiDAR works is. Okay, see what happens is, can you see here? Huh? See, a LiDAR scanner also works in the same fashion. Only thing is, can you tell me the coordinate of this point? No. So, a scanner does like this only. You can see, no? The scanner does this way only. To get the position of the each laser point, we use what is called as the GNSS on board, and there is one more device called as the IMU, inertial measurement unit, which gives you the attitude of the platform. GNSS gives you the position of the platform X, Y, Z. That IMU gives the tip of the platform till the roll of the platform and heading of the platform. So ultimately, to get the coordinate of this point, it uses the laser rangefinder and position information from GNSS and the orientation information from the inertial measurement unit. So what happens is each point gets the location information. That this is how the LiDAR technology works. Clear? Yes? No?
Technology is from the Schrodinger wave equation.
Schrodinger, how it will be? It's a pulse laser. It's not how it comes. It's quantum. Actually, we measure, this is basically a ranging principle. The signal travel time of the pulse similar to radar. Maybe I don't know, continuous waveform LiDARs are also there where the Schrodinger equation may be in place. Quantum mechanics. Because this is basically a pulse LiDAR that goes in. Because I am also from physics. Okay, you are clear? Just I don't want to complicate. Yes, laser scanner scans the ground. This can come, you can go up to 10 points per square meter. 1 meter by 1 meter, you can go up to 10 points per square meter. Next slide, please. You are getting it here, and this is an additional technology. It can penetrate through the vegetation, and you can get the terrain information under what? Under the trees also. So can you see here? Here can you see under the top of the tree is red, bottom is the terrain. Fine. It is called as a point cloud because massive points are available with known XYZ coordinates using the laser rangefinder information as the GNSS and IMU information. Next. Just to take through the process, you get next I will show the next one. This is how you do a flight plan, and then this talks about what is the spacing of the points. What is the spacing of the points on the ground? If I ask I don't know, nobody is here from civil engineering. If I ask him to get the coordinate of a point x by z, say 110 points, 20 points in a day is gone. Whereas I can acquire thousands of square kilometers within 1 to 2 days using this technology on board here. Okay, so precise terrain information is required. Tomorrow when you are going to inquest, you can see that. Next. I don't want to get to the break line part of it. I think I thought maybe I found civil engineers and geologists are also there, but no, I don't want to venture into this. What I want to come back, the next. What we do is with this, the so-called break line, we are trying to flatten the water bodies because this is an infrared laser. It cannot penetrate through water and it doesn't give precise information in case of water. There are other sensors. This is the topographic glider. If you want to get the underground profile of any water body, you have to go for a bathymetric glider. Bathymetric means terrain underneath the water. If you want to get, there are gliders available, which are called as bathymetric gliders. Next. Again, to get the flow direction, how the water will flow, uphill to downhill. So to get the flow direction, we do what is called the break line. Next. So this is for the ISRO disaster support program. This is nothing but the surface model, which is ground, top of the tree, top of the building. I filter it to get only the bare, and then this is an auto image which I can use for 2D mapping, and this is the map. Fine. These data sets are where it is being used as flood simulation, inundation modeling. If I give you a railway station along the river, we have done for major river basins of the country: Mahanadi, Brahmaputra, Kosi, Godavari, Ganges, so many places we have done. Okay, this is for flood inundation mapping, and I have shown you a case of urban flood modeling which we are doing now for Hyderabad. Next, this is again for Brahmaputra river basin. Next, you are able to go back. This is basically a surface model, a terrain, ordering it, and the map that is being made. If your AIML experts can bring a map which is being done manually, at least 80% of this. Okay, so that should be a goal. At some point of time, it is going to happen, no doubt about it. Be part of the process. Next, because the throughput is around an operator can capture 1 square kilometer in 1 man day, that is 8 hours. Manually will be digitizing in front of the system, mouse capture the line, polygon and the point. Next, go back. This is what you are going to see tomorrow when you are going to go to inquest. We have done the entire, after the tsunami, we have done 2 kilometers from the coast landwise, inward, from the coast 2 kilometers in land inward, right from Gujarat coast to Sundarbans. And these data sets are being inquest for tsunami inundation modeling and coastal vulnerability maps. For that, surface digital terrain model, ordinate and 2D maps have been given. So they will be running this tsunami modeling. Already tomorrow they will tell you how scenarios have been built. Now we can give alerts within 11 minutes, so that we have hotline connections and all with the respective collectorates in the coastal areas. So, and I have seen some of the villages have sirens also. From the collectorate, they press the siren. They have been trained through mock exercise how, in case of a siren, which place island they have to move. So that 11 minutes is what the alert can be generated and can be sent. So this is one of the real world application of how the airborne lidar with associated data is being used for disaster management. Tomorrow, maybe I think there are many people. I think Mr. Mahendra will also be there. Just see, just ask what are the data sources, what are the different places, data sources that have gone, what are the different systems. It's not only this data set, there are different seismic stations and other things are being used. Next. This is for again copy, we are using same technology. Next. Okay, what will happen is if I use spacing is nothing but I think the ladies will understand. Rangoli, if I put Rangoli points every 1 meter, this is the type of Rangoli you will get. That's them you will get. This is spacing at 10 meter. The point spacing between each elevation point is 10 meter. You can appreciate here, right? Even streams are coming out very nicely. As I go to 30 meter, it gets diffused. So the residual space accuracy is one aspect, and even the spacing is another important aspect. Next. Again, this is for the Tapi river. You can see 1 meter, 10 meter, and 30 meter. How it is a resampled DTM. These are all grid. There is another concept of 10. I don't want to get into it. Next. See, this is again he told us the same terrain model. How you depict with reference to the contour height, isolines. Next.
Sir, in terrain model, you will not be considering the man-made things.
Yeah.
So, what is the use of that?
No, we will give both the data sets to the people. They can simulate with and without.
But why with and without?
With that, what are certain applications? Because if I give you a culvert or a bridge information from the top will actually block the water flow. Actually, in a culvert and a bridge, what water will do? Underneath the culvert, water will go inside, right? If I don't cut at the bridge or something, you are getting the point. I have a bridge. If I don't give only the surface model, what it will show? It will be like a compound wall which will be obstructing the water on the left hand side. Whereas a bridge or a culvert has an underpass where the water will go to the other side. So these are all the things we have to take care. Next, this is for again don't want to get into this. This is basically for forest application. Since this radar technology can penetrate through vegetation, you can get the height of the tree volume and the bearer, which is used for biomass estimation. Biomass estimation is used for climate science because forests are important carbon sink. Carbon emission is a big problem, right? Whereas forest is very critical for the carbon absorption. So the biomass related activity as part of your climate change related commitments and all that, this is very critical for technology for getting the biomass availability in the country. Next. Again the same thing in the case of how the canopy model, tree top looks, surface model and terrain model. Next. Again the same thing, maybe madam was asking what is the difference. Normally this is basically when we are talking about the same camera, it is a push broom camera. Here you can get stereo. Here in the aircraft it's a systematic acquisition. Whereas in case of satellites, when I go in one orbit I acquire like this, and when I go in other orbit I can look the other way. Now we have very agile satellites, we can tilt and rotate in directions and get images. Okay, so I don't want to get into this. Similarly, stereo images can be obtained using satellite. Sometime back it started with 10 meters. We are right there 30 centimeters with satellite. The spatial resolution. GS. Okay, next. Again, what are the step processes to derive the different three-dimensional maps, ortho images? Always all this are DSM, DTM, ortho image, 2D map and 3D map. 2D map is planimetric map, 3D map is topographic map. Next. This is again for one of the terminal project. Next. This is the contour information. Next. Next. This is the landslide in Utkal and Jammu and Kashmir. Just to show you next slide. Next slide. Next. You can see the red portion. How the land has slided. The landslide in the Utkal area. Using this is nothing but a terrain model to show the impact of landslide. How they actually block the river and because of that lot of impact happened. Next. So before that, our video play is there. Video better. Okay, after that we'll have. I'll try to complete it faster. Don't bear with me. I'll just complete just to show you. It should be able. This is the terrain model of Kosi River basin, wherein this is the terrain model generated using lidar data. The automatic effort is going to be 70. The remaining 30% is going to be manual effort. You can see the river, right? See, this data is put into a different flood simulation tools, and tomorrow you will be seeing what is called the tsunami modeling solution. How they have done the scenarios using the tsunami L2 modeling. Okay, I think you can close this one. Other one you can show. This close this. Full view. Full view. This is part of your financial district. I think I don't have time to reduce the play speed. Okay, just to give an impression that how the surface model looks like. This is the Musi River, I guess. Anybody from this area? Can you locate exactly? Okay, fine. Adi drone unda. Drone madam WhatsApp పంపించారా? WhatsApp. Maybe ఆ తర్వాత పెట్టమని UAV slide పెట్టేసి. Just I try to complete okay, and so far we have been seeing mostly on the aerial platform. Now basically the UAVs are increasingly used. Only thing is, I think if you have seen the Vjit, West Asia or other places or America, this one, they use a huge drone, big ones. But as far as even Indian defense forces have big ones, and even defense labs have big ones. Whereas for civilian users, we have been restricted to fly at 120 meter maximum. And that too in, I think you can, people who are interested in drones can see the digital sky platform of the DGCA, the Directorate of Civil Aviation. If you are getting into like UAV flying at some point in time, you can visit this, and then wherever there is a green zone, you can fly at 120 meters, and your drone should be in your visual line of sight. That means from your operating point, it should not go beyond 450 meters. So these are all the restrictions, and that's why we also initially were planning to go for a big one. But so we have restricted ourselves to a small one. Basically, it can bridge the gap between the satellite and aerial, and also it provides very high resolution, and it has got a different application. Rapid data collection, small area, rapid data. If I want to acquire in a farm I want to measure the agricultural growth of a particular crop in a given area, for canopy height modeling and other things, I can keep on deploying every week to monitor the status. In case of agricultural universities, they will have different fields with different crop infestation, and then they will be monitoring what is the impact of the pests and diseases on a given crop and all that. So how to, by applying certain dosage of fertilizer, how it improves. This type of monitoring small areas, drones are very ideal platform. Not for bigger areas, with the small drones. If you are showing like predators, your global hawk or the herons, whatever they are using for defense related, we can as well fit the big sensors, whatever I showed, the aerial and the airborne lidars on that, and then we can acquire large areas also. Okay. So we have a Vjit, and we have this is similar to a madam was asking, this has got red edge, near infrared, and then thermal infrared band also. This costs around 12 lakhs, and the weight of this is around 570 grams only. So all miniaturized sensors with drones. Okay, and what you see on the right, on your right is the ortho image of Tumkur town. Next. Again, standard process, flight planning, GNSS for trajectory estimation, GCPs, then you do the processing, then you generate. These are the products. So in our today's lecture, I was kept on telling surface model, terrain model. What he told means at least you tell Narendran told surface model, terrain model, ortho image, 2D map and 3D map. Fine. Next. And these are all some of the projects we have done for different applications. Next. This is how a drone data looks, and once you see now what if I want an AML expert to count the number of plantations in a given thing, and next go one step further, determine the canopy diameter to infer on the health of the crop, health of the plantation. That is the level thing. That is the one you should be focusing on. Okay. So, what is training data set required for you to carry out this? How much will be your training data set in your any CNN or your ANN model? Okay. Now, if I want to classify only this, because whenever I give this type of work to my subordinates, no, always they tell them I want training data set. Okay, then I will ask you how much. Okay, it is whenever it is a training data set is critical, I understand, but maybe you have to come up with some of the optimizing techniques for given studies, and these are all the real thing which is really useful to get. See, people are now working on drones, getting the health of the crop, and then pesticide and fertilizer spraying. Because I need not spray fertilizer everywhere. No? Wherever it is required, I have to spray to the required amount. People are working in this direction, and people are thinking, can I acquire the drone data on board, do a edge computing, derive an actionable product, so that the same drone or the other drone, that information has to pass to the other drone, and then go for pesticide spraying and other things. So if somebody is interested in going for some entrepreneurial initiative, you can think in this direction. Next, this is again surface model of the same area, because ultimately this will give you the height, ground height of this one, and from that you can compute the biomass, and you can keep on monitoring this type of thing. Okay, next. And this is the Puttumala landslide. This was done before the recent landslide. Why in a country like India where disasters are very common, it's better to have high resolution data sets at regular intervals. Most of the time what we do, we wake up at the end and then do a small study. That is not the real requirement. You should have a national level database very often, so that this type of things can be taken up for that. This type of studies can be anticipated, because the rainfall was building with the particular orange alert or whatever it is. Then you can simulate something, and if you have to be in a position to give the real before time information, because at some point of time we used to have a lot of casualties in case of cyclone. That we have overcome. It's high time that we have to come up with a good terrain information for other, particularly the landslide related applications. Next. And this I don't know whether how many of you saw the RLV landing at Chitradurga? Raise your hand. One. You have seen the RLV landing of the reusable launch vehicle of ISRO landing at the Chitradurga. If you have not seen, go and see. In that also for the touchdown, this surface model of the runway has been used. Because as the unmanned vehicle, the reusable launch, it's unmanned. It has to have the terrain information, and it has on board some information to measure the height. Based on that, it try to land on the ground unattended. This is the Chitradurga. I will not share this just for your information. You can just go through the launch which is available in video. Next. Next. Just to show, I think this is for the answer. Skip. Next. This is for the Jaria coalfield, where you can see, I think what you can see. This is basically, you can see Jaria in there is fire, high thermal emission, and there is fire on the active fire and overburden dump. So this type of monitoring, we cannot go very near to this, whereas for a small area, drones are ideal platform. Next. I think this is what I want to tell. The future is in this area, the digital twin. This I have generated using a synthetic, this one, for a part of Surat, which you have done as part of the topic thing. This is also one critical area. Somebody is interested, you can help us in coming with a digital twin for a given, because we have a lot of data. We can really nicely develop this one, and on top of this, we can see ultimately creating is not enough. It's just for visualization. Actually, you have to integrate different IoT sensors. Suppose if I want to see what is the traffic flow at Gachibowli junction at this point of time, I should get the real feed into this. That should be the way. And suppose if I want to have a rain gauge station connected to this, I should see what is the rainfall that is happening in near Charminar. So like this, we have to.
Can we remove the noisy atmospheric data using digital?
Noisy. See, in this case, we are very close to the. See, we are just 2 kilometers. 2 kilometers. I think that is for image processing related activity. That's what, right? You want to tell atmospheric monitoring.
Like supposing the data is noisy and I need to pre-process the data.
That is all being done, no? It's being done, no?
No, with digital twin.
With the digital twin, how will you do?
Actually, a speaker was talking about this.
Or else what you can do is you take a good data available and then try to simulate for that condition. That can be done. I was told the same thing, because where there is a cloud cover, they try to substitute from simulate other data set. Yeah, that is being done. I have not seen it. This again for pollution monitoring at different junctions. You know, if I keep carbon dioxide, carbon monoxide sensors at the signals using smart sensor and bring that, I can monitor the pollution and I bring in the wind sensor information onto this. In direction of the pollution movement can also be simulated. So the next revolution, if at all, is going to be happening in this country is in the domain of digital twin, but integrating so many light IoT sensors and other feeds, so that we can really simulate onto for. I think you can. Next, and it has got plenty of applications. Next. Maybe I think you show that UAV video, no? I have another 5 minutes.
Yes, sir, you have.
Maybe I'll come to this later. Just I want a video pictures. This is the VTOL. This is the UAV which will take off as a helicopter and fly like a fixed wing. This we have flown near Badrinath in Himalayas at an altitude of 3,200 kilometers, 200 meters. We'll have separate discussion. See what happens. This is going to be. See, I have just introduced. We have 2 rounds of a discussion. No, we can show you other data sets so that you get ideas. I guess even I tell my daughter also, but she comes to me actually. Okay, if he hears me, I think he'll call me right away. Okay, so I have been telling, but I am seeing maybe I don't know the generation. Yeah. See, this is near Badrinath in Himalayas, 3,000 meters is the altitude. See, this is a project which we have done. And I think some of your youngsters, I think you are really good hands in going in the area of drones. And see, youngsters play like anything with that, because I've seen a lot of engineering students, because we are slightly afraid because we are old, whereas the camera is at the belly. What is the mark in that? This is what is seen on the ground control station where the flight is going. Okay. This is on the ground control station where the flight is happening. That information is coming from through the telemetry. You can see that. Takes off and lands like a helicopter, and then goes like a pigwee. And you are not supposed to catch a drone like this. Okay, okay. Yeah, you should not catch a drone like that, because terrain was like that and they have done it. Never ever do that, because there are rotors which rotates at a very high RPM rotation per minute, which accidentally there are always chances of cutting. Okay. See, just the next technology I just want to tell you is maybe another 5 madam will tell me.
10 minutes.
10 minutes. Okay. Maybe the next LiDAR. I think I bored you people. Sorry. I thought of giving a break, but I'll complete this also. Again, you have a LiDAR here. This is the LiDAR head. What it does is, you mount on a vehicle. This does a circular scan. See, it does a circular scan. And due to the movement of the vehicle, it continuously gets that like a pipe type of thing, three-dimensional information. What you see is near the Aicte city, near the Aicte Atal location, and it has got a 360-degree camera as well, which gives you the panoramas. And this is nothing but the point clouds. We can get point cloud of every this one up to 3,000 to 4,000 points per square meter. Okay, that is the level of information you have. See, you have an along track means in the direction of the vehicle movement, you get a point every 4.5 centimeter, and across track direction every 6 mm. I go in the vehicle, every in the forward direction for 4.5 and in the across track direction 6 mm. So this is used for number of applications. Come down. Next slide. This is for near the Cse-Aiml road is further, same route, no? This is the Moinabad, Cse-Aiml Moinabad, this one where they want to, our team has done identification of the road parameters for this highway. For this mobile technology has been used. Okay, next. Next. This is for again part of this one Tanban road, estimating the road width, shoulder, pedestrian, and other information. Next, and this is again we have used machine learning in terms of, I think people have used random forest and deep lab V3 for this. Next. Again measuring the road cross section, road width and other parameters. Next. Again this is the one where we have integrated the UAV LiDAR along with MMS LiDAR to get the complete profile of the tree canopy. Again this is useful for, as I told, for climate related studies and biomass estimation, which is really required for sustainable development, environment monitoring and also the climate emission goals. Next. This is a coffee plantation in Cse-Aiml. We derived the ground bare earth, that is the terrain, and this is the original point cloud. Next. This is how you derive the. See, basically you have to get the tree trunk detection and then get the biomass for the entire tree. One is to get the canopy cover and also diameter of the trunk at 1.3 meter, which is called the DBH. Diameter of the breast height 1.3 meter to get the biomass. Next. Next, you identify the trunk. Next, you just compute the DBH at different cross section along the trunk. At the particular location, and then you get the estimate the height, and you compute the diameter at the breast height, and then you compute the biomass. Next, with this I conclude. Hope you got some information. Any questions?
Sir, we do navigation recently, one of the reasons. Is it only for military application or
We do is from China. We can also track it. Civil, or even India has got a civilian signal as well as a defense signal, restricted signals. So we do as also have the same. They have the same thing. Even the Americans have that. One is called as a CA code. Another one is called the P code. I have not got into the detail of it because even you can speak GNSS and GPS for 3 hours. I understood that then I was not focusing much on certain things because I am not what we learned over 25 years. I cannot try to impose in 2.5 hours. Just to create some interest in the focus. Thank you. Thank you very much for. At least nobody slept, that much I ensured.